For more than a century, the greatest scientific minds have pursued one dream: to recreate the power of the sun here on Earth. Nuclear fusion, clean, limitless, eternal, the holy grail of energy. But decade after decade, the world heard the same words. Fusion is 30 years away, and always will be. Billions were spent. Supercomputers were built. Gigantic reactors rose from the ground. And after 100 years of research, the result is the same. Not 1 watt of usable net energy has ever powered a home, a city, or even a light bulb. Until now. In 2012, one scientist, inventor Konstantin Tomoiu, confronted a simple question: why has no one succeeded? And more importantly, is there a different path? In just 15 months, scientist, inventor Tomoiu achieved what the world's most powerful institutions could not accomplish in 67 years. A new form of hybrid chemical thermonuclear fusion, TICF, Tomoiu Internal Confinement Fusion. Unlike all traditional fusion programs, TICF does not use radioactive tritium. TICF does not rely on massive external electrical power. TICF produces no radiation. TICF leaves no hazardous waste. TICF runs on ordinary water. Inside each reactor, molecular hydrogen and protium are extracted from water, and a chain of microplasma reactions creates clean, measurable, continuous net energy. This is not theory. This is demonstrated reality. On April 11, 2013, the Tomoiu Alpha reactor produced continuous net thermal energy in an independently observed test. This was the moment fusion changed forever. Between 2012 and 2022, scientist, inventor Tomoiu built and tested 10 reactors, all showing the same result: real net energy, clean net energy, replicable net energy. These reactors were validated at City College of New York, CCNY, University of Maryland, College Park, 5 additional independent laboratories. This makes TICF one of the most externally validated fusion technologies in the world. TICF reactors were tested and confirmed by leading experts. Professor Ashwani K. Gupta, PhD, University of Maryland; Professor Marco Castaldi, PhD, City University of New York; Dr. Kiran Bura, University of Maryland; Professor John Duher, PhD, Adelphi University; Professor Norman Ostroff, PhD, University of Connecticut; senior scientists from EMSL, Barron Consulting, Columbia MD, and Brook Environmental. These are independent scientific authorities, all confirming TICF produces verifiable excess energy beyond chemical limits. On November 19, 2024, at Pond Cafe in Hartford, Connecticut, 2 TICF reactors, Alpha 2 and Gamma 3B, were demonstrated live. The results: Alpha 2, input 4.033 megajoules, output 10.286 megajoules, Q equals 2.55, net energy equals 6.256 megajoules. Gamma 3B, input 1.704 megajoules, output 10.661 megajoules, Q equals 6.256. Net energy equals 8.957 megajoules, measured, verified, documented. On May 29, 2025, the TICF Crusader reactor was tested in front of U.S. Steel Corporation executives. The results: total input, 29.021 megajoules. Total output, 132.166 megajoules. Net energy, 103.145 megajoules. Q equals 4.554. Later tests achieved. Q equals 5.476. Q equals 8.377 industrial level validation. Witnessed and signed. To understand TICF's success, we compare it to the world's largest fusion programs. JET, 40 years, 350 scientists, 1,000 plus megawatt input, 24 megawatt output for 3 seconds. Net performance, Q equals 0.004, 3,000 cubic meters of radioactive waste, over $300 million to dismantle NIF, DOE's National Ignition Facility. Size, equivalent to 3 football fields. Cost, $3.5 billion. Fuel, deuterium-tritium, radioactive. Fuel availability. Tritium is extremely scarce. Energy input, greater than 400 megajoules of electrical energy. Energy output, 3.15 megajoules thermal only for 20 billionths of a second. Q value, approximately 0.0078. Massive energy loss of 99.2%. Practicality, 0. Not usable for power generation. Claimed breakthrough was based on partial accounting, not true net energy. TICF is 452 times more energy efficient than NIF when comparing Q values. NIF is experimental and non-practical, while TICF achieves real, continuous, clean fusion power with positive net energy. MIT requires supercooled magnets at -196 degrees Celsius. Needs 50 megawatts just to heat plasma. Requires up to 155 megawatts flywheels. Still unable to deliver net energy. Sandia National Labs. Single pulse, 2.132 terawatts. 100 times U.S. energy demand. Produces destructive X-rays and shockwaves. Not suitable for power generation. TAE Technologies focuses on proton-boron 11 fusion via FRC reactors. Requires extreme temperatures, 3 billion degrees Celsius. Has not yet produced net energy. Helion Energy, Inc. utilizes deuterium and helium-3 in FRC systems. Struggles with the scarcity of helium-3 fuel. Faces unavoidable high-energy neutron and X-ray radiation. Lockheed Martin. Cancelled. NASA LCF uses gamma radiation. Unsafe and impractical. The conclusion: traditional fusion is trapped behind its own physics. TICF is not. At the University of Maryland, under Professor Ashwani K. Gupta and Dr. Kiran Bura, the TICF Gamma-3 reactor produced results beyond chemical explanation. Measured temperature, 732 degrees Celsius. Expected, approximately 90 degrees Celsius. Performance index, Q equals 2.1578. These values confirm micro-packet-level nuclear fusion events are occurring, cleanly, safely, and continuously. The team concluded, the results are very promising for clean energy generation. After years of rigorous testing, validation, and refinement, TICF has produced something unprecedented. The world's first working miniature nuclear fusion power plant, not simulated, not theoretical, fully functional, producing continuous, clean, net energy. TICF is ready to power the world. The future of energy begins now.